Hey again. All right, so we left off at number 11. We finished number 10, so try to do number 11. And this one's a relatively quick one, but it takes a little bit of just thinking about. So we have, kind of draw this situation out. We have a kid on top of a chair, and the chair rolls. So the kid is going to jump this way. And when he does, his acceleration is going to be 3 meters per second squared. Sorry about all this thing. I don't know why it's messing up. 3 meters per second squared to the left. Oops, redraw. Do it right. 3 meters per second squared to the left. And the kid is 60 kilograms standing on a 2 kilogram chair. So, we have to figure out the magnitude and direction of the acceleration of the car. So, I think a lot of us would be able to realize that the car is going to accelerate that way. But how much is what we're trying to find out. Well, Newton's third law says that F of A on B equals negative F of B on A, meaning different directions. So, the force of the kid on chair equals the force of the chair on the kid. The force of the chair on the kid is what accelerates the kid because it's on the kid. So that force, which is there's only one, so that's the net force, is just the mass of the kid, 60 times negative 3 for the left, which is negative 180 newtons. Force of the kid on the chair, since the chair is pushing on the kid, making the kid go to the left, the chair has a force to the right. And that force is the mass of the chair times the acceleration of the chair. And the mass of the chair is 2 kilograms, times the acceleration of the chair. So, solving for A of the chair, it's, I think, we're not in room here. The acceleration of the chair is going to be negative 180 over 2, which is going to be negative 90 meters per second squared. And this is where something goes a little weird because the whole net force, actually we shouldn't have the 0 because it means a direction. The net force is 0 because it's all enclosed, everything's the same. So really this should read F of A on B minus, because they're in opposite directions, F of B on A equals 0. So when you solve that, you get a plus, which gets rid of that. So that's sort of my apologies. If you had a negative, it's not a big deal. But really because it's positive, one of those circumstances where the A doesn't really work out very greatly. You get positive 90 meters per second squared to the right. It's really big. Seems like a really big number, and it is. But when you think about it, a chair, when you try to jump off of it, it really does zoom away fast, but it's not accelerating for a very long amount of time. You're only in contact with it for just a little bit. So in terms of the physics, it works pretty well. Alright, so like I said, pretty quick problem. Moving on to 12, a little bit more complicated of a problem. You're going to rearrange your bedroom by moving bed in front of the window. Who cares about that? Bed has a mass of 98 kilograms. When I see mass, I change that to weight, 98 times 9.8 to get just a weight, Fg, of 960.4 newtons. Alright, we have to coefficient of friction, just sort of listing our knowns. Coefficient of kinetic friction is 0.35. You apply an applied force, 490 newtons to the left. Draw the forces acting on the bed. What is the normal force? What is the kinetic friction? Alright, so we have our bed. We're pushing with an applied force, FAPP, of 490 newtons. We have an FG of 960.4 newtons. We have a normal force of 960.4 newtons because there's no other vertical. And we have a force of kinetic friction on the bed. Alright, What is the normal force? We took care of that. Very simple. What goes up comes down, or what goes down goes up. So normal force 960. What is the kinetic friction force? The kinetic friction force is just mu k times the normal, 0.35 times 960.4, 336.14. So add that up to our free body diagram. Newtons. Okay. Kinetic friction force is done. The net force, F net, is mass times acceleration. We don't know the acceleration yet, but we do know that it also equals right force minus left force. So that's 336.14 minus 490. 336.14 minus 490. Negative 153, so our net force is 153.86 newtons to the left. That's what that negative means. We know that the mass is 98, so we can solve all of this. Say 98 times A equals, because we're trying to find the acceleration, negative 153.86. Solve for A by dividing. You get negative 1.57 meters per second squared, or you could say 1.57 meters per second squared left. Either way, good to go. 13 and 14 I don't have on here, so I'm just gonna wipe this out. Blank page. 13 and 14 were just new problems. You had the following force diagram, really, and we had Fg of 300 newtons. You have a normal force you're trying to find. You have an up and over force where it's 16 degrees at 70 newtons. Looking for FFK. This is a tension force, FT. And we know that mu k equals 0.23. Alright, so we got to find Fn, FFK, and the acceleration. Alright, so first thing, when you see the arrow, you want to break it apart to FTY and FTX. FTY is going to be 70 times the opposite side of the triangle is my sine, so 70 sine 16, and my FTX will be 70 cosine 16. So 70 sine 16 is 19.29. And 70 cosine 16 is 67.29 as well. 29 newtons. Okay, so redrawing this free body diagram a little bit more simply, I'm going to drop the labels themselves, just keep the numbers. We have 300 going down. We have two forces acting up. We have the FTY, which is 19.29. We'll have our normal force. We have our FFK, and we have our FTX, which is the 67.29 newtons. Alright, our normal force, all the vertical forces have to cancel, so we want to subtract the 19.29 from the 300 because that's already taking away some of the 300. So the normal force in this case is going to be 300 minus 19.29. Decimals don't want to work today. 300 minus 19.29 is 280.71 newtons. Alright, so found that. We also got to find FFK, but FFK is mu k times the normal force. Mu k is 0.23, it was given, times 280.71, 64.56 newtons, and then we got to find the acceleration. We were given the weight, so the mass is the weight divided by 9.8. which is 30.61 kilograms. So our mass times acceleration equals our right, which is our FFK minus our FTX. Mass is 30.61 times our acceleration. FFK we just found, 64.56, minus our 67.29. 64.56 minus 67.29 gives us 30.61 times A equals negative 2.73. We expect it to be negative because it's moving to the left. Divide by 30.61. I won't write that step out, but you know to do it. 30.61, and you're going to get an acceleration, small one, of negative 0.089 meters per second squared, or 0.089 seconds squared to the left. Either way. Perfect. Alright, I think I will finish the next question on a final screencast. So, good job.